So first, we'll begin with the module one, stresses and strains. So in that, the first topic is mechanical properties of materials. So as you know, there are different types of materials. So we have to study their properties first. So basically, we have studied the physical properties, that is the density, and electrical conductivity, thermal conductivity, specific gravity, melting point. So these are studied in your lower grades. So those are called as the physical properties. The chemical properties, you also study the chemical properties, that is a composition, structure, etc. So now, so these are the mechanical properties, which means these are very helpful for the mechanical working of certain materials. So in that, the first one is elasticity. It is defined as the property of material to regain its original shape after after deformation when the external forces are removed. So when the external force are applied, it goes deformation. It undergoes deformation. It goes change in shape. So when the loads are removed, it goes back to its original shape. Such property of a material is called as elasticity. It can be referred as power of a material to come back to its original position after deformation. When the stressor load is removed, is also called as tensile property of the material. So elastic, just like the rubber. So for example, a rubber, when pulled, it elongates or it changes its shape, size. So when the load is, when we stop pulling, when we leave the rubber, it comes back to its original position. So rubber is a best example for elasticity. So next comes plasticity. Second uh, mechanical property is called as the plasticity. So plasticity is exactly the opposite of the elasticity. So plasticity is defined as the mechanical property of a material that retains the deformation produced under the load permanently. This property is required in forging, in stamping, images or coins or ornament work. Means it is ability of tendency of material to undergo some degree of permanent deformation without its rupture or failure. Plastic deformation takes place only after the elastic range has been extended. Such property of material is important in forming, shaping, extruding many other hot and cold working process. Materials such as clay, lead, etc. Plastic at room temperature. Steel is plastic at forging temperature. So plasticity basically means, so just like the plastic. So when it is heated, we can mold it in any shape, and we can, when it is cooled down, it regains that same shape. So the given shape. So when, or any other, suppose a rod, steel rod, when we bend it, it uh, it goes deformation, and when we leave the load and we remove the loads, it does not go to its original position or same position. It remains in the same state. Such type of uh, properties of a material is called as plasticity. So this plasticity is helpful in many engineering works such as stamping or extruding, making coins, wires. So these are helpful in different ways. So next is the ductility. So it is termed as the property of material enabling it to drawn into wire or with the application of tensile load. So property of material, so the material which can be drawn into wires is called as ductility. This property is called as ductility. So ductile material may be strong and plastic. It is strong, but as well as it is plastic, it can take shape of a wire. Ductility is usually measured in terms of percentage elongation and percentage reduction in area, which also is often measures of ductility. The material that possesses more than 5% of elongation is called ductile materials. So material has to be more elongate more than 5% to be called as ductile material. So ductile material is commonly used in engineering such as mild steel, ductility, mild steel, copper, aluminum, zinc, tin, etc. are the some of the ductile materials. So this was about the ductility. Ductility means nothing but property of material to drawn into wires. Next, to the fourth one comes malleability. So this also is a similar property like ductility. So malleability is a property, a ability of material to be flattened into thin sheets under the application of compressive force without cracking or uh, by hot or cold working means. It is a special case of ductility which permits material to be rolled into thin sheets. So malleable material should be plastic, but it should be essential. It not be very strong. So maybe malleable materials commonly used in engineering practice are lead, soft steel, wrought iron, copper, aluminium, tin, lead, etc. are highly malleable. So malleability means forming into thin sheets. So with the compressive loads. So when the load is applied, we can spread the sheets. We can have elongation in all three directions. Such type of ability is called as malleability of a material. So this is highly in aluminum. So aluminum can be flattened aluminum, copper, tin, lead, steel, etc. They are highly metal, unlike plastics. So brittleness. It is a property of material opposite to ductility. It is a property of breaking material with permanent distortion. The material having less than 5% elongation under loading behavior are said to be brittle materials. Brittle materials are subject to low tensile load snap off without giving any sensible elongation. Just like glass, cast iron, brass, ceramics are considered brittle material. Brittleness means without if the material is elongates less than 5% under loading condition is called as brittleness. Just like the glass, so glass cannot be elongated just like rubber. So such materials are called as brittle materials. So next comes strength. Strength, it is defined as the ability of material to resist external applied forces without with, without breakdown or yielding. With breakdown or yielding, the internal resistance offered by a material to extremely applied force is called stress. Capacity of bearing load by metal and to withstand exertion under the load action of external load is known as strength. The stronger the material, greater the load it can withstand. This property of material therefore determines the ability to withstand stress without failure. Strength varies according to the type of loading. It is possible to assess tensile, compressive, shear, torsional strengths. The maximum stress that any material can withstand without before destruction is called ultimate strength. So strength, it is the ability of material to withstand the highest force of that material. So it can, if the stronger the material, higher the strength, higher the load it can uh, vary. For example, aluminium is weaker and steel is stronger than aluminium. Steel can take up more loads than aluminium. Also, more than titanium is again strengthier than steel or aluminium. Next is hardness. Next topic is hardness. Hardness is defined as the ability of material to cut another material. Harder material can always cut or put an impression on softer materials under its hardness. It is very important property of metals has a wide variety of meanings. It embraces many different properties such as resistance to wear, scratching, deformation, and machinability, etc. It also it also means the ability of material to cut another metal. Hardness is usually expressed in term numbers which are dependent on the method of making the test. Hardness is of metal may be determined by following test: Pinel hardness test, Rockwell hardness test, Weaker hardness test, Shore scaloscopy. So hardness means it is ability of metal to cut on the metal or to make impressions or dent on another metal is called as hardness. So hardness and strength are two different topics, two different things. They are not the same. Strength is nothing but ability to take loads. Hardness is nothing but ability to cut other material or to make a dent on the softer materials. So, for example, diamond is a hard material. It can be used to cut other materials, but it has but the strength is but the strength of a diamond is low. So when we hammer the diamond, it breaks, but so it does not have high strength, but it has high hardness. It can make a dent on a steel surface also. So hardness is dent making or the cutting of the softer materials is called as hardness. Next is toughness. It is ability of metal to absorb energy without rupture. The So, like example, the rubber, plastics. So they do not shatter or break. So therefore, they are very tough. For example, if a rod is made of high carbon steel, it will bend without breaking under the impact of hammer. While if a rod is made up of glass, it will break by impact loading. Toughness of metal decreases when it is heated. It is measured by the amount of energy of per unit volume of material has absorbed being stressed up to the point of fracture. This property is desirable parts subject to shock and impact loads. So that's why we have so it is ability of metal to absorb energy without fracture rupture. So rubber padding, rubbers and plastics are mainly used where there is high loads, high impact loads or shock loads. So this property is called as toughness. Creep. When a part is subject to constant stress at higher temperature for a long period of time, it will undergo slow and permanent deformation called creep. This property is considered in designing internal combustion engines, boilers, and turbines. So any part which is subject to high stress at high temperature, constant stress at high temperature, it will go deformation. Next, resilience. It is a property of metal to absorb energy and to resist shock and impact loads. It is a measure of amount of energy absorbed per unit volume within the elastic limit. This property is essential for spring materials. It is the amount of energy absorbed per unit volume within the elastic limit. So it is a so how much of a spring can take a load. So that amount is nothing but resilience. So that measure is nothing but the resilience. Fatigue. A material feels at stresses below yield point, which is subject to repeated tensile stress. A type of failure known as fatigue. So this is considered in designing a shaft, gears, springs, etc. Failure is caused by means of progressive crack formation, which is usually fine and microscopic size. Now, difference between malleability and ductility with example. Ductility is the ability of metal to undergo deformation without under tension, without rupture. Malleability is the capability of metal to undergo under compression or without rupture. Ductility is a property of material by virtue which is drawn into wires. The property of virtue was drawn into thin hammered rolled thin sheets. It is tensile property. Malleability is a compressive property. Ductility depends on the grain size of the metal crystals. Malleability depends on the crystal size of the material. So example are mild steel, copper, aluminum, zinc, nickel, tin, etc. So malleability gold, silver, aluminum, tin, zinc, rod, iron, etc. are the examples of malleability.